Hello students, good evening. Welcome to APJ Academy. So, how are you all doing? Let me just check the YouTube. Okay, then we'll start the session, because in between the session, if you want to ask any questions, if I am not online with the YouTube, then it will be difficult for me to give you the answer. So please bear for just 1 minute. We'll start in a minute. Yeah. Yes. Okay. All set. Okay, students. So today we are going to discuss about a new topic from the chapter Atomic Structure. Okay. Yes. Okay. Now this is all about our full year course. You can see on your screen that what all things we are providing for one long year. We will be providing the PDF materials, which consist of all the modules and the bank of questions, and also we will be giving you all the test series, because we know that without practicing more and more questions, competitive exams cannot be cracked. Okay, then there will be query solving. We will have one-on-one mentorship program. So whatever doubts, whatever things you have to ask, you have doubts, you can clear it off so easily, and we have an expert panel for that. And you know that all the lessons will be provided with the correct thorough explanation of the concepts from base to the higher level. Will be taking you, and also for each and every aspect or every chapter we have assignments. Okay, so assignments will be provided after every lessons. Okay, right. Now this is the course fee, and you can see that we are providing the high quality content just for rupees 490 per month. So you can crack JEE or NEET with this enormous discount. That's the major feature of our course. Okay. And those students who are viewing this channel for the first time, see, we are giving quality content in YouTube channel for free. So you can subscribe to this channel. If you like our classes, you can enroll for our class. Okay, you can be part of APJ Academy and join hands with us. We can take you to crack the competitive exam, to help you fulfill your dreams. So if you are a new student or a new viewer of this channel, you can subscribe our YouTube channel. It is for free, and we are providing quality content for JEE as well as for NEET aspirants. Okay, let's move on to the next one. Okay, students, this is all about me. You can read about myself. You can read what I am, who I am. Okay, yes. Next, quantum numbers is a chapter we are going to discuss today. Actually, quantum number is not a chapter. In fact, it's a small topic that comes in the chapter called as atomic structure. We have been discussing atomic structure for the past 3 sessions. We discussed about the topics of atomic structures. You know that we discussed about the Bohr model. We discussed about the applications of Bohr model. We discussed about the hydrogen spectrum, absorption spectrum, emission spectrum. Then we discussed about the wave atomic model, where we learned what is Heisenberg principle and the dual nature of matter, and all these things we discussed. And also in each session we have done numerous questions which are the potential questions which will be asked for your exams. And now we are moving on to the last segment of this chapter, atomic structure, that is quantum numbers. Hi Nandana. Okay, now quantum numbers, let's discuss what is quantum number. See, first of all, you have to understand one thing. That is, quantum numbers are those numbers which are used to identify the presence of an electron. That is what you have to understand at first. Okay, in order to identify an electron, you need an address. See, if a friend of yours is staying out of Kerala or out of India, let's say, or out of somewhere where you are out of the state where you actually live, if previously if they wanted to contact you when there were no mobile phones or any internet connections, what they normally use, they use postcards, right? Or they used to write letters in which they cover it with an envelope, and out of the postcard or the outside face, what they write the name of the receiver to whom the letter have to be delivered. They write the full address. Why they are writing the address? They are writing the address because there can only be one person who have that address, so that the postman can come and give the letter to whom you wanted to deliver that letter, right? So this is, address means what? Address is an identification factor or an identification element with which we can identify a person, right? So actually address means it's a location where you stay. It is a locality, or the location where you stay is called as the address. Okay, similarly, if you want to find out where an electron, a particular electron is staying, you need an address. But the address of the electron is different. It's not like that of ours. It is different. It consists of 4 numbers actually. Like, you know, we have a unique identification number called as Aadhaar number. Okay, each person have each number, and that if you type the number in the central government website, you can extract the complete details of that person. Okay, actually it cannot be done because of the privacy reasons, but the government officials can do that. If you want, if you do any crime, if we know the Aadhaar number, then the police can type in and identify or understand all the features regarding you, your address, everything, whatever, even your bank account, your PAN card number, everything can be detected from that. So Aadhaar number is a number which gives the complete details of ourselves. Similarly, if you want to identify an electron, you require certain address, or you can call it as a number that is similar to Aadhaar number. So here also we have 4 numbers to identify an electron. Like, let's say if I'm a person who's staying outside India, I wanted to connect to a person, or say in any other state. Okay, let's take the example within India. Okay, and first of all, what I write the name of that person, right? Then I write the place where he stays. Then I write the district where he stays, and then I write the state. Okay, state. Okay, these are the 4 things that I require in order to deliver my letter to that person. In order to identify that person, I require these 4 datas. So the state is something that is similar to principal quantum number. Okay, if I am living in Kerala, or if I am living in Delhi, say if I am living in Delhi, then this is what indicates the first level of information regarding me, where my locality is. So I am living in Delhi. Delhi is not a state, in fact it's a union territory, whatever, let's take it as an example. Okay, so I am just writing it with my state, that is I live in Kerala. Okay, now in Kerala, where is my locality? In Kerala, we know there are lots of different districts. So I say my district is Calicut or Kozhikode. I say in Kozhikode district. In Kozhikode, we have lot of locations, right? So this district corresponds to azimuthal quantum number. So first it comes the principal quantum number. It gives you a wider view. a larger view where the electron is, and in that larger area we know that there are lots of electrons are present, but we are searching for a particular person. Now we have to bring it shorter. Now in that principal quantum number we are searching for the particular district where this person lives. So that district is azimuthal quantum number. So azimuthal quantum number, then we check the azimuthal quantum number or the district where that particular electron lives. Okay, we got the district. Now what's it? We know that in that particular district there are a lot of localities, there are a lot of places. So now we come with the place and the house name. Okay, now the place, this can be a house name. Okay, I'll give it as house name. So we got the place. It can be somewhere like Maavoor Road. I just giving a place, Maavoor Road. Okay. So now we are coming closer to that electron. This place indicates the magnetic quantum number or the exact locality where this person is living. Now we only need one more thing. In that particular place, or we can include that place or house name similar to that. In that particular house there are a lot of people. These two can be considered as one, place and house number. That corresponds to magnetic quantum number. Okay. Now we know that in that house there are many persons, many people will be living. So we have to exactly give the name of the person. So name of the person is something that will clearly deliver the letter to that person. So that name of the person is actually what? That is the spin quantum number. So with these four quantum numbers, we can easily identify an electron, or these quantum numbers are similar to our Aadhaar card number, where by just giving that number to a software or where you can elicit all the details, if you type in that number, all the details regarding that person can be obtained. Similarly, we can obtain all the details of an electron if you know these four quantum numbers, and these four quantum numbers are quantum numbers which helps us to find out where the electron lies in an atom, where the electron lies in an atom. So just read the definition that these are the numbers which can determine the position of an electron in an atom. So these are the numbers which can determine the position of an electron in an atom. So how many numbers are there? As I have given analogy regarding the home address and the quantum numbers, we have four numbers are there, and they are represented as N, L, M and S. What is N? N is the principal quantum number. Here you can see. That means, what do you mean by principal quantum number? It is the shell, or you can call it as orbit where the electron lies, or it is similar to the state where you live. Okay. Now in that shell there are subshells. So in which subshell, or you can call it as in the state, there are districts. So in which district is this person living? Similarly, in a shell we have subshells. So in which subshell they are living, that is indicated by azimuthal quantum number. Azimuthal quantum number tells us in which subshell the electron is living. So within the subshell there are many orbitals. There are many orbitals. Okay. See, shell is also represented as orbit, but orbitals and orbit are different. Orbit is another name for shell. That is what you have to be clear of. Okay, certain students have some doubt regarding that. They may say that, sir, sometimes they say that there are orbits, sometimes they say that there are orbitals. So actually understand this, orbits and orbitals are two different things. Orbits is shell, simply shell. Okay. So within the shell you can see the subshells, and within the subshell there are many orbitals. Okay. So orbitals means the boxes, that boxes, you know, for S subshell there is only one box. For P subshell there are three boxes, and these three boxes are called as orbitals. Okay, so there are number of boxes or number of rooms present in a subshell, and that room is called as, or that boxes are called as magnetic quantum number, and it is denoted by the value or represented as M. And now if you find out in which room this person is living, then we know that if you are considering an atom, each room consists of 2 members. That is, 2 electrons will be present in each orbitals. So, understanding the name of that particular person, we can find out we can easily find out which person is that. So, the name corresponds to the spin quantum number. That means in an orbital, I have told you that there are 2 electrons. And what do you mean by spin quantum number? We know that if one electron is rotating clockwise, then the other electron will rotate in anti-clockwise direction. So, if you want an electron with the clockwise direction rotation, then you will write plus half. That is the name of that electron, plus half. If you call plus half, that means that is a particular electron. Okay, if you call it minus half, then you are asking for the electron which is rotating in the anti-clockwise direction. Okay, so these are the 4 quantum numbers which helps us to find out the position of an electron. So, first of all, there will be a shell or an orbit. Within the shell, there is what? There is subshells, and within subshells, we know that in state, we know that there are districts. In districts, there are localities. In locality, there are many persons. Okay. Similarly, principal quantum number is orbits or shells. Within shell, we know that there are subshells, and within subshell, there are different orbitals. And in each orbital, there are 2 persons. Either of the one will be our electron for whom we are searching for. Correct? Right? I think this is clear for you. And now we will move on to the principal quantum number. And as I have told you, principal quantum number is nothing but it's an orbit or a shell, or you can call it as an energy level. It represents the number of orbit. Which number orbit is the electron is living? See, if you consider the nucleus, first orbit is the orbit that is closer to the nucleus. Second orbit is the orbit that is in the second position from the center of nucleus. Third orbit is that, or third shell, or we can call it as orbit, is that orbit or shell which is from the third position from the center of the nucleus. Okay, so this is what the principal quantum number all about. So you can see that there can be n can be 1, 2, 3 or 4. What do you mean by n equal to 1? N equal to 1 means the first orbit, that is from the nucleus, the first orbit. Okay, from the nucleus, if your electron is present in the second orbit, then it is n equal to 2. From the nucleus, if your electron is present in the third orbit, then it is n is equal to 3. From the nucleus, if your electron is present in the fourth orbit, then we represent it as n equal to 4. See students, you might have studied this in your exam or in your classes, that the shells are also represented in alphabetical order. Like if it is the first shell, then we represent it as K shell. Second shell we will represent it as L shell. Third shell or third orbit we represent as M, and fourth one we represent as N. Actually we deal with 7 shells because we have 7 periods. Okay, in the periodic table we have 7 periods, and each period corresponds to the number of shells. Okay, so that means in total in an element there can be 7 shells can be present. Actually, in actuality, there are infinite number of shells. But what does the 7 shell means? Because in the 7th period elements, you know that there are 7 periods. In the 7th period elements, the valence electron is present in the 7th shell. So we consider that 7 shells where the electrons are present. So likewise, we only studied about K, L, M, N shells. Normally the teachers teach them only 4 shells, but that is wrong. There are 7 shells. You can also write it as K, L, M, N. After 4, you can have 5, you can have 6, you can have 7. So the fifth shell corresponds to K, L, M and O, then sixth shell corresponds to P, and seventh shell we write it as Q. So according to the periodic table, we can have 7 shells with electrons present. Okay, right. Now coming to certain data or certain facts which you have to study, that is the maximum number of electron in a given shell. If you want to find out the maximum number of electron in a given shell, what you have to do? You have to just multiply or use this formula to find out the value, that is 2n square. What do you mean by n? N is the number of shell. In which shell the electron is present. If it is first shell, let's say, if it is first shell, then the number of electrons present in that shell is 2 into 1 square, that is 2. If it is the second shell, then the number of electrons is 2 into 2 square, that is equal to 8. If it is the third shell, then that is 2 into 3 square, that is equal to 18. Okay, so this is all about the number of shells and how many electrons are present in each shell. Now coming to the maximum number of orbitals in a given shell. See, one thing you have to understand is that, so here orbitals means what? Orbitals is something I have told you that it is the rectangular boxes. Like if you say S subshell, we have S, P, D, F, 4 subshells are present. For S subshell, we have 1 box. For P subshell, we have 3 boxes. Okay. For D subshell, we have 5 boxes. 1, 2, 3, 4 and 5. And for F subshell, we have 7 boxes. 1, 2, 3, 4, 5, 6 and 7. We have 7 boxes, right? So what you have to understand is, for S subshell, we have, in S subshell there is only 1 box, that means there is only 1 orbital. This is what you have to understand. In S subshell there is only 1 orbital. In P subshell there are 3 orbitals are present. In D subshells there are 5 orbitals are present. In F subshell there are 7 orbitals are present. Okay. So if you are asked to find out how many orbitals are present in a given shell, then you can just simply use this formula, that is n square. That means in the first shell, you will have how many orbitals? 1 square orbitals, that is 1 orbital. For second shell, you will have 2 square orbitals, that means 4 orbital. In the third shell, you will have 3 square orbitals, that is 9 orbital. I'll later explain how we got 9, 4 and 1 practically. Okay, I'll later explain that. Because in order to explain that, I have to go through the subshell concept. When I explain the subshell concept, I'll explain how I got 1, 4 and 9. Practically how we are going to get the number of orbitals, I'll be explaining there. Okay. So these are the major things. First of all, how to calculate the maximum number of electron in a given shell? The formula is 2n square. You have to use this formula 2n square, that is n corresponds to the value of the number of shell. And maximum number of orbitals in a given shell is equal to n square. That is, in a shell, how many orbitals are present. And one more thing you have to understand is, this one also I have already discussed, that is, in one orbital there are 2 occupants. That means in one orbital there will be 2 electrons, which is having, one will be having a clockwise rotation and the other will be having an anti-clockwise rotation. Okay, in 2 direction, one is clockwise rotation and the other is anti-clockwise rotation. So each boxes will have maximum of 2 electrons present. Okay. Now, what is the angular momentum in orbit, in shell? What is the angular momentum? That is what Bohr have already taught us. The angular momentum in an orbit is equal to nh by 2 pi. So these are the 4 facts that you have to primarily understand from principal quantum number. Hope this is clear, students. Please let me know whether it is clear or not. Okay, 4 things. One is maximum number of electron present in given shell. How to calculate? Just use the formula 2n square. If you are asked to find out the number of electrons or the maximum number of electrons present in the first shell, just put the value 1 in the formula 2n square. If you want to find out the maximum number of electrons present in the second orbit or the second shell, then just put the value 2 in the place of n in the equation 2n square. Okay. Similarly, maximum electron in an orbital is equal to 2. That already have told you, that is in one box the occupancy is equal to 2. Only 2 electrons can be occupied in a room. See, if you are studying in hostels, we say that in a hostel room only 4 students can stay. Okay, that's what we limit them. Similarly, in an orbital only 2 electrons can be occupied, not more than that. Less than that can be possible, 1 can occupy, but maximum how much? 2 electrons. So angular momentum in orbit is equal to, what is the angular momentum? We know that the electrons are revolving around the nucleus, right? So if they are revolving, obviously they will have momentum, and if they are in a circular motion, then what kind of momentum they have? They have angular momentum. If they are moving in a straight line, this is physics, this is not what? This is not chemistry. If they are moving in a straight line, then they will have what? They will have linear momentum. Okay, so if they are revolving around the nucleus, then they are in circular motion. In circular motion, an electron will have angular momentum. And Bohr sir told us what is the angular momentum of an electron in an orbit. That is equal to nh by 2 pi, where n stands for the principal quantum number. If the electron is revolving in the first shell, then its angular momentum is equal to h by 2 pi. If the electron is located in the second shell, then its angular momentum equal to 2h by 2 pi. If the electron is present in the third shell, then its angular momentum is equal to 3h by 2 pi. So that's very simple, right? Now let's move on to the next concept. Yes, this is, we are from state, we are going into the district. That means we identified the shell or the orbit where the electrons are present. Now we wanted to minimize the locality, we wanted to specify the locality where actually our electron is present. So now within the state we are searching for the district where actually the person whom we wanted to meet is staying. Okay, so we are going into the district, and that district is called as azimuthal quantum number, and it is denoted by L. So clearly student, please understand this. This is so simple concept that if I am taking the first shell, if the value is n equal to 1, that means it indicates the first shell. First shell means from the center of the nucleus, the first shell. Okay, we count the number of shells from nucleus to backwards. Likewise, we count the number of shells. So from nucleus, the first shell. So in the first shell, if the shell equal to 1, then that particular shell will only have one subshell. One subshell. If the electron is present in the second shell will have two subshells. So the number of shell and number of subshells are same. If the electron is present in the third shell, that means that third shell will have 3 subshells. This is a basic information that you have to understand. Many students make mistakes in this area. So the first shell can only contain one subshell. The second shell can contain only how much subshell? 2 subshell. The third shell can only contain 3 subshell. Now, if that is clear, now we will move on to the values or the indications of that shell. So we know that I have told you, if we are talking about the first shell, how many subshells are possible? Only one subshell. So we denote it by the value 1 less than that of the shell. That means if the shell value is 1, then that particular subshell will be L equal to 0. And that subshell is called as S subshell. S subshell. So the first shell will only have one subshell. Which is that subshell? That subshell is S subshell. So in the case of S subshell, the S subshell will only have one orbital. That means one room. And that one room is normally denoted as m equal to 0. Actually, this is not the part of subshell, but in fact, it is a part of what? It is a part of magnetic quantum number that will come to the next slide. We will discuss about that. But you have to be clear about this. Now, if I am talking about the second shell, so tell me, in the second shell, how many subshells are possible? For the second shell, two subshells are possible. What are they? They are L equal to 0 subshell is possible and L equal to 1 subshell is possible. That means those two subshells are S subshell and P subshell. P subshell is indicated by 1, L equal to 1. And understand this, S subshell will have only one box, but P subshell will have three boxes. The center box is denoted as m equal to 0 and the left one is denoted as m equal to -1 and the right one is denoted as m equal to +1. Okay. Now let's move on to the next one. If I am talking about the third shell, now tell me, how many subshells are possible? If the number of shell is 3, if you are discussing about the third shell will have 3 subshells. What are they? S subshell, P subshell and D subshell. So S subshell is L equal to 0, P subshell is L equal to 1 and D subshell is L equal to 2. So this is S, P and D. So S subshell will only have one room, P subshell will have 3 rooms and D subshell will have 5 rooms. 1, 2, 3, 4, 5. So the center room will be 0. For left we will give minus value. For right we will give plus values. Is it clear, students? Is it clear? Okay. Now similarly, if you are considering about the third shell, for the third shell we will have third shell we already discussed. Now if you are taking the fourth shell, for fourth shell there will be 4 subshells. What are they? S subshell, P subshell, D subshell and F subshell. So S subshell we normally denote it by L equal to 0. For P subshell we normally denote by L equal to 1. For D subshell we denote by L equal to 2 and F subshell we denote it by L equal to 3. Okay, and F subshell, remember F subshell have 7 boxes. That means 7 orbitals are present for F subshell. Okay, now let me take a new page. Here, let's see this. We already have told that the maximum number of electron in a given shell is equal to 2n square and the maximum number of orbitals in a given shell is equal to n square. Now let's take the practical application here. If I am considering about the first orbit or the first shell, tell me how many electrons are possible, because before that tell me how many subshells are possible. For the first shell only one subshell is possible. We know that if n is equal to 1, then only L equal to 0 is possible. That means S subshell is possible. Okay, S subshell means only one orbital. So tell me how many number of electrons possible, maximum number of electrons. We know that for one orbital, for one room, how many electrons can be occupied? 2 electrons. So here we can say that it is equal to 2. Now, if I am talking about the second shell, for second shell, there will be how many subshells? 2 subshells. What will be? N equal to 0, that is S subshell, and L equal to 1, that is P subshell. So for L equal to here the number of subshell is equal to, sorry, it's not number of subshell. Okay, let me write here maximum number of orbitals. So for maximum number of orbitals, for n equal to 1 is equal to 1. So if n equal to 2, that means here we know S have 1 box and P have 3 box. Okay. So total number of orbitals is equal to 4 in the case of n equal to 2. Okay. Each orbital contains 2 electrons. So 4 into 2, that means 8 electrons will be present in the second shell. If you are taking the third shell, we know that for third shell, there can be 3 subshells, L equal to 0, S subshell, L equal to 1, P subshell, and L equal to 2, D subshell. So here you have to understand how many subshells are possible. In that case, we have already told how many shells are, which shell you are denoting. If you are denoting the third shell, then 3 subshells will be there. And how their indications are like this. It will be L equal to 0 to n minus 1. What does this n minus means? N minus 1 means if you are talking about the third shell, then it starts with 0 to 3 minus 1, that is 0 to 2. So 0 to 2 will be the number of subshells that will be present in the case of n equal to 3. So always the L value will be equal to n minus 1. That is what you have to. Yes, Abhiram, I am still there. Okay. That is what you have to understand. Clear? So L equal to 0, S subshell, L equal to 1, P subshell, L equal to 2, D subshell. So L equal to 0, S subshell is 1 box, L equal to 1, P subshell will have 3 boxes, L equal to 2, D subshell will have 5 boxes. Okay? Clear? So total number of boxes, how many boxes are here? We know that 5 plus 3, 8 plus 1, 9. So 9 boxes are present. That means 9 orbitals are present. Each box contains a maximum of 2 electrons. That means 9 into 2, 18 electrons are present in n equal to 3. That means the third shell we have 18 electrons. Is that clear, students? Is that clear? So now let's come back to the formula. In order to find out the maximum number of orbitals, what I did the formula, use the formula n square, right? For the first shell, n square equal to 1 square, that means the maximum number of orbitals is 1. If n equal to 2, then the maximum number of orbitals is equal to 2 square, that is equal to 4 orbitals. If n equal to 3, then the maximum number of orbitals is equal to 3 square, that is equal to 9. See how we got? This is the practical explanation of the formula. Now coming to the maximum number of electrons, formula is 2n square. Okay. Now apply the value of n here. If you are asking about the first shell, put 1 here. So 2 into 1 square is 2. Now 2 into 2 square is 4 into 2, 8. If n equal to 3, then 2 into 3 square, that is equal to 18. So this is all about the maximum number of orbitals and maximum number of electrons present in the n shell. Hope this is clear. Now we will move on to the next topic. Yeah. So we just completed about the maximum number of electrons in the shell. Now let's discuss about maximum number of electron in the given subshell. How are we going to understand the maximum number of electron present in the given subshell? So here is the formula, 2 into 2l plus 1. Okay, see, if I say how many electrons or how many maximum electrons can be occupied in S subshell. S subshell means what is the value of L? L equal to 0. For P subshell we know that L equal to 1. For D subshell we know that L equal to 2. And for F subshell we know that L equal to 3. These are the values of the subshells. Okay. Now, let's see how many electrons are present in each subshell. 2 into 2l plus 1 is a formula, right? So in S subshell we know that there is only 1 box. That means there is only 2 electrons. Let's put the value of L here. 2 into 2L plus 1 means 2 into 0. Value of L equal to 0 for S subshell. Now plus 1, that means 2 into 1. 2 into 1, that is equal to 2. So that's what we obtain here. Now for P subshell, how many maximum electrons are present? See, actually we do not require this formula, right? For P subshell, we know that P subshell contains 3 rooms and each room contains a maximum of 2 electrons. That means how many electrons? 6 electrons. Let's check it with the formula. 2 into 2L plus 1. 2 into 2L plus 1. That means what is the value of L for P? L equal to 1. So 2 into 1 plus 1, that is 2 into 3 equal to 6 electrons. And similarly for D subshell, we have 5 orbitals. For D subshells we have 5 orbitals. Each orbital have maximum of 2 electrons. Likewise we have how many electrons? Total 10 electrons, right? So total 10 electrons. By using the formula you can find out 2 into L. L value for D subshell is 2 plus 1, that is 4 plus 1, 5. 5 into 2 is equal to 10. So likewise, first of all you have to understand the concept properly. Then what you have to do, then you can use the formula. Okay. Now similarly, how to find out the maximum orbital in a subshell? Another equation, 2L plus 1. Actually, if you know, if in S subshell we know that maximum orbital is 1. For P subshell maximum orbital is 3. For D subshell maximum orbital is 5. For F subshell maximum orbital is 7. So if you know that value, then we do not require that formula. So that's it about the subshells. Now in the subshell, what electron is doing? Electron is rotating in the subshell. So obviously it will have what? It will have angular momentum, orbital angular momentum. In the first case we have discussed about the normal angular momentum of the electron in the shell. Similarly in the subshell also electron will have what? Electron will have angular momentum, and that angular momentum is called as orbital angular momentum. And what is the formula of orbital angular momentum? That is the root of L into L plus 1 h by 2 pi. See, h by 2 pi can be represented as h bar. There is another representation of h by 2 pi, that is h by 2 pi can be represented as h bar. So if you see in the question paper like an expression like this, h bar, then don't worry, it simply means h by 2 pi. So root of L into L plus 1, root of L into L plus 1 into h bar. This is also a formula for orbital angular momentum, right? Okay. Now let's do some problem. See, orbital angular momentum of 2s, 3p, 4d and 4f. Actually, what is the formula of orbital angular momentum? That's what we have studied here. What is orbital angular momentum? Root of L into L plus 1 h by 2 pi. So angular momentum, orbital angular momentum is equal to root of L into L plus 1 h by 2 pi. So now let's see 2s. Here you only have to consider about s, no need of this 2. Okay, because in orbital angular momentum the only value we require is L value, right? We only require L value. So what is the L value of s? Tell me, what is the L value of s? L value of s is equal to L equal to 0. Now you can substitute that value, 0 into 0 plus 1 h by 2 pi, that means you get an angular momentum, orbital angular momentum of 0. Now 3p, so here the answer is, angular momentum of 2s is 0. Now for 3p, for p, we only have to consider the subshell if you are asked about the orbital angular momentum. Okay, so for p we know that L value equal to 1. So now what is angular momentum? 1 into 1 plus 1 h by 2 pi, that means root 2 h by 2 pi. That is the angular momentum for the orbital p. Now for D the L value, the L value is equal to 2. That means what will be the angular momentum? 2 into 2 plus 1 h by 2 pi, that is equal to root 6 h by 2 pi. Similarly for F, we know that for F the L value is equal to 3. So what is the formula? 3 into 3 plus 1 h by 2 pi, that means 3 into 4, that is 12 h by 2 pi. Okay students, is that clear for you? So it's a very good question, right? Orbital angular momentum. If orbital angular momentum, you have to remember this formula and apply the value of L. We only have to know what L is, right? Now coming to the magnetic quantum number. So magnetic quantum number means it is the location where the electron is present. So we know that in a subshell there can be number of locations. Like for S, we know that there is only one location, that is there is only one orbital. For P, there can be 3 locations for P subshell. For D subshells, there can be 5 locations, 1, 2, 3, 4, 5. And for F subshell, there can be 7 locations, 1, 2, 3, 4, 5, 6 and 7. So we have to identify in which location or in which room our electron is present. So that information is given by the magnetic quantum number. That information is given by the magnetic quantum number. And each orbital will have each magnetic quantum number value. Okay, that means if for S subshell there is only one orbital, that means we give it as 0. We call it as m equal to 0. Actually, what is the value of m? M is equal to minus L to 0 to plus L. What does that mean? It means if I am considering P subshell. For P subshell, we know that there are 3 values or 3 orbitals. And what is the L value of P subshell? We know that it is 1. That means the 3 orbital will be minus 1, that is minus L, then 0, that is 0, then plus 1. These are the 3 values we give it for 3 orbitals. The center one will be given as 0, left one will we give it as minus 1, right one we give it as plus 1. This is how we represent the magnetic quantum number. Okay. Now the next is, if you are discussing about D. For D, we know that there are 5 shells. So how the numbering or how the values of magnetic quantum number will be? For D, we know that L equal to 2. So the value will be minus 2 to plus 2. Minus 2 to 0, 0 to plus 2. That's how it goes. So the center orbital will be 0. The left one is minus 1. Then the left one is minus 2. The right one is plus 1. Then the right one is plus 2. Likewise, we give the indication of each orbitals. Is that clear, students? Please let me know in the comment section. Okay, you can, if you have any doubt, you can ask in the comment box. Similarly, if it is clear, you can just inform that it is clear. Now if you are considering the F subshell, we have 7 orbitals in that F subshell. So for F subshell, what is the value of L? L is equal to 3. That means M can be minus 3 to 0 and 0 to 3. So the center orbital you give it as 0, the left one is minus 1, then the left is minus 2, then the left is minus 3. Similarly, from 0 to right, plus 1, plus 2, plus 3. So we have 7 orbitals here, we have 5 orbitals here, we have 3 orbitals here, and we have 1 orbital here. Is that clear, students? If this is clear, everything will be clear for you from quantum numbers. Okay? So you have to focus on the concepts. If the concepts are crystal clear for you, then no question can break you down. Okay. Now we are moving on to the spin quantum number, the last and the final quantum number that represents the name of that person. We know that in an orbital, maximum of 2 occupants can occupy. That means 2 electrons can occupy. But we have to identify which electron we are pointing it out. Okay, for that we need a specific quantum number to identify which is that electron which I am searching in that 2 electrons, because the nature of the 2 electrons are same. But the only difference is the spin of the electron is different. That means one rotates to the right. If one electron is rotating to the right, then the other electron will rotate to the left. That is the difference in their spin, and that spin will help us to identify which electron we are searching for. If they are spinning along its axis, so electron is rotating in its own axis, so that rotation will also have an angular momentum, and that angular momentum is called as spin angular momentum, and the spin angular momentum is equal to S into S plus 1 h by 2 pi. So here we know that if an orbital have 2 electrons, that means there are 2 spins, and we indicate it by plus half or we indicate it by minus half. Plus half indicates the clockwise spin, that the electron is spinning in the clockwise direction, like the clock. You know, the clock rotates in the clockwise direction, right? Similarly, the opposite direction is called as anti-clockwise. So if the one electron is spinning in the clockwise direction, then the other will be rotating in the anti-clockwise direction. So S equal to plus half indicates the clockwise direction rotating electron, and S equal to minus half indicates the anti-clockwise electron with the anti-clockwise spin. Okay, so this is all about the quantum numbers. Okay, these are the 4 quantum numbers which you have to study so that you will get a clear picture of what the quantum numbers are. Now, I hope this is clear, students. Please let me know in the comments that if it is clear for you or not. If any doubt also you can ask, so that I can clarify your doubt here itself. And after this session you can do problems if you have any material with you, so that you can practice certain problems with quantum numbers. Okay, I guarantee you it will be, you can do that if you have concentrated in this session, then you can easily crack every question that can be asked from the quantum numbers. So here, see, write all the 4 quantum numbers for 4p orbitals. Here we have to write all the 4 quantum numbers for 4p orbital. So what do you mean by this 4p? So first one, 4 indicates the principal quantum number, that is n is equal to 4. Okay, n is equal to 4. If n is equal to 4, that means the shell is 4th shell. How many subshells are possible? 4 subshells are possible. Which are they? They are L equal to 0, that is S subshell, L equal to 1, that is P subshell, L equal to 2, that is D subshell, L equal to 3, that is F subshell. Here they have specifically asked about the P subshell, so I need not have to use these 3 orbitals. I only have to write the azimuthal quantum number as L equal to 1. So our azimuthal quantum number is L equal to 1. This is, in total we call it as 4p. But the picture never ends there. In L equal to 1, that is in P subshell, we know that there are 3 orbitals. So the 3 orbitals are, one is 0, minus 1 and plus 1. 0, minus 1 and plus 1. 0, minus 1 and plus 1, that means m equal to 0, minus 1, plus 1. So in each we have, this is the magnetic quantum number. Now we have to write the spin quantum number. We know that for spin quantum number there is only 2 spin quantum numbers. What are they? S equal to plus half and S equal to minus half. These are the 2 spins that an electron can have. If an electron is having a clockwise spin, then obviously the other electron will have anti-clockwise spin. So this is how you write all the 4 quantum numbers for 4p orbital. So n equal to 4 means it indicates the, here if it is 4p, 4 indicates the shell. So principal quantum number is equal to 4. P is the subshell. What is the subshell number? For P, L is equal to 1. We know that for if L equal to 0, that is S. L equal to 1 is P, L equal to 2 is D, and L equal to 3 is F. So here L equal to 1. And for if L is equal to 1, then it can have 3 magnetic quantum numbers, that is minus L to plus L. If L equal to 1, then minus 1 to plus 1, that is minus 1, 0 and 1 plus 1. These are the 3 magnetic quantum numbers possible, and for spin quantum number it can only have 2 values, that is plus half and minus half. Okay, is that clear? Now let's move on to the next question. Calculate all 4 quantum numbers for the last electron of rubidium Z equal to 37. So this is a very good question. See, they have given us the atomic number rubidium, that is 37. Okay, and we know that rubidium is a member of alkali metals. Alkali metals means the first group: lithium, sodium, potassium and rubidium. Okay, so lithium is present in where? Lithium is present in the second period, sodium in the third period, potassium in the fourth period, and rubidium in the fifth period. Okay, and we must know, see, actually if you have studied the periodic classification, then you know how to write the configuration. But here I am just giving you the configuration, that is the configuration, electronic configuration of rubidium is, valence electronic configuration of rubidium is 5s1. Okay, so let's see, actually when you will get to know it is 5s1 after completing the third chapter, but now for time being just understand that it is 5s1. Okay, because rubidium is in the 5th orbit and it is the s block and it is in the first group of the s block, that means the electronic configuration will be 5s1. So we know that. What is this 1 means? 1 indicates that in the s subshell there is only 1 electron. Okay, now we are going to write all the 4 quantum numbers. Now we got that principal quantum number is equal to 5. Azimuthal quantum number can have 4 values, no, 5 values, right? If the shell is 5, then there can be 5 subshells, but we only need to study about 4 subshell. Here it is, they have given us S subshell. For S subshell, what is the value of L? L equal to 0. We know that if the subshell is S, then L equal to 0. If the subshell is S, then what is the magnetic quantum number? We know that for S there is only 1 orbital. So that 1 orbital we denote it by 0, m equal to 0. M equal to 0 is the only box or only room that the S have. If it was P, then P have 3 rooms, m equal to -1, m equal to 0 and m equal to +1. Now what about S? S can be plus half or minus half, because it consists only 1 electron. So that 1 electron can have clockwise rotation or anti-clockwise rotation. So it can have plus half or minus half. Okay, and this question was JEE main question. And why I wrote this? Because see, these 4 only I require these 4 because they have given the clear-cut information that the 4 quantum numbers for the last electron of rubidium. So we only have to consider the valence electronic configuration of that electron or that particular metal or particular element. Then we have got all the 4 quantum numbers present for that electron. With this quantum number we can clearly understand which electron we are pointing it out. Okay, so this was a previous JEE main question. Okay, so students, that's all for today. We have discussed about all the 4 quantum numbers in detail and we have done some numericals regarding that. Hope this is clear for you. Please let me know in the comment section if it is clear. Please let me know that if it's clear. or if you have any doubt, please let me know. I can give you 1 or 2 minutes more. Okay, please let me know that if it is clear or not. So what you have to do next is you have to practice some problems from this particular topic of atomic structure, quantum numbers. If you have listened to the class carefully, then I can guarantee that all the concepts regarding this will be clear for you, so that you can easily go and easily solve every problems. Okay, so I hope everything is clear for you. So let's wind this session, and we will meet in the next class. Until then, bye bye and take care and good night, guys. Thank you.